Guys, hello, welcome to my channel again. Today I will continue with the bash scripting tutorial that I have started last week. A couple of days ago actually. And let's see, I was in the last video I was actually checking for the basic shell operations, and we created a file. It's called sample directory. And here we created different files, and the last one was actually the basic operations continued. So let's open this file first. Not this one. Let's create this one. Basic operations continued.sh. Here I have checked the value of the expressions, some basic arithmetic operations. So let's clear this file, or let's open a new one. So let's make a new directory called, I was checking the arithmetic operations, and now let's check the relational operations. So let's say relational operations. The keyboard sound is a bit of annoying, so relational operations.ch. So let's say we have, first we need to put the shebang in.sh, right? Bin.sa, bin/sh, and then we need to put so let's create two variables. Let's say the first one is a, which is, let's say, 10, and b, let's say, which is 20. And now we can check the relational operations of these two variables. So for example, we can echo, where is it? Yeah, we can echo if we can basically test for the equality of these two variables with this statement. Where's the other one? Yeah, it's here. So let's give it a try. Quit. We need to make this executable, of course. And yeah, it prints the statement because, as you remember, we need to make this an expression. We need to actually put backtick. Let's try now. Not found. So xpr. Now let's try it now. I had a mistake here somewhere, so okay. So we can echo this actually with let's get rid of this and this one. We can echo this one, and let's try B and A. Yeah, but this echoes as a text. We want to echo it as an expression. So you can basically copy this and paste Ctrl-Alt-C, and you can open ChatGPT and we can ask for, or Ctrl-V. That's the read only. Let's try it like this. Copy, paste. How to echo the value of this expression. Yeah, so here and here it shows a bit different. So if, then A equal B, then echo A equal B, I mean A is equal to B basically, else B is not equal to B, and the file. Yeah, because we didn't close the if here. Open it again, edit. Insertion mode, and we need to close this if. Then A is not equal to B. So in the 7th sentence, here we had a problem. The problem is related to that. Should I say 7 not found? Let's take this, copy and paste. Now get rid of this, quit. I don't know what's the problem with the first statement, so I will just check it out. Your encountering is due to the missing spaces around the square brackets. Missing spaces around the square brackets. So it's basically you need some square brackets, you need some spaces here. Yeah, now we don't have any problem with that. So as you can see, there's a space here between the square brackets and the first and the second variable. So let's look at the second one. The first one was checks if the value of two operands are equal or not. If yes, then the condition becomes true. Checks if the value of two operands are equal or not. If values are not equal, then the condition becomes true. So I know it's so silly, but actually we may check for all of them with an E. In this case, when this returns true, checks if the value of two operands are equal or not. So not equal. So if not equal is going to return not equal. If they are equal, they are going to return equal. So it's going to be like this. And for the other ones, again, yank it and paste somewhere here. And the third one is GT, checks if the value of left operand is greater than the value of the right operand. Greater than. The left is greater than the left is greater than the right. Left one is A, greater than. Left one is A, which is 10. So if A is greater than 10, we will return A is greater than B, else A is not greater than B. A is not greater than B. A is not greater than B. We can check for the others as well. Checks if the value of left operand is less than the value of the right operand. If yes, then the condition becomes true. It's greater than, and we also have the less than. We will replace it with less. Is less than, is not less than. So this will return A is less than B. Checks if the value of left operand is greater than greater than checks if the value of left operand is greater than or equal to the value of the right operand. Greater than or equal to, so GE. Let's see. GE, A is greater than or equal to B, greater than or equal to B. A is not greater than or equal to B. Is not greater than or equal to B. Checks if the value of the left operand is less than or equal to the value of the right operand. So we can also check for that as well. We need to yank this part, put it here. Now it's going to be not greater than or equal to, less than or equal to. And we will replace this part with less than. And then is not less than or equal to B. Is less than or equal to B. So as you can see, the things that we print, I didn't replace the text here, but you can basically replace everything here to check for the equality. And there is the example here. So there are various operators supported by each shell. We will discuss in detail about Bourne shell, the default shell in this chapter. We will now discuss the following operators: arithmetic operators, relational operators, Boolean operators, string operators, file test operators. Bourne shell didn't originally have any mechanism to perform simple arithmetic operations, but uses external programs, either AWK or exp. The following example shows how to add two numbers. So like, let's make add two numbers.sh in.sh. So you have the value, which is an expression 2 plus 2. Don't forget about the spaces. There should be spaces between these elements. And you want to echo total value, which is the value of this expression. So when you make this file executable, plus x, add two numbers. Now as you can see, total value is 4 here. The following points need to be considered while adding. There must be space between operators and expressions. For example, 2 plus 2 is not correct. It should be written as 2 space plus space 2. The complete expression should be enclosed between the backticks. There are the arithmetic operations I checked. We already checked these actually. So we have the Boolean operations. This is the correct. There should be space here. Boolean operators. The following Boolean operators are supported by the Bourne shell. Assume variable a holds 10 and variable b holds 20. And the following Boolean operators are supported by the Bourne shell. Assume variable a holds 10 and variable b holds 20. We can actually check for these. The Boolean operators.sh, bin.sh. So we need to check for the Boolean stuff. Let's say a is 1. Okay, so when you echo if this is going to be 0, so it's not going to execute. You will echo a is 1, else echo a is 0. So now this is going to be 0, and then this statement is not going to execute, but we need spaces here, I think. Look at the examples for the Boolean expressions. there's always a space. Yeah, but there is also space here. chmod plus x boolean operators, and then let's execute it. Expected then. We need to replace this. I was just then. I hope that's the only problem that it encountered. So a is 1 and a is 0. It prints 2 times. The reason is a is normally 1 and a is normally 1, so not a, which is 0. Let me see. You can basically copy and paste it. So this, the output, it prints both of them, right? It prints both of the echoes statements. What to do to avoid it? Yeah, I basically don't take this variable. Let's try now. This should print A0. Again, prints the same. This prints A is 1. Because if A is 1, if A is 0, this will be 1 and this will print A is 0, right? If A is 0, this is going to be 1. So this is going to print A is 0 and then A is going to 1. I'm not sure if that's correct. Let's see. Again, it prints the same thing. If this is going to print A0, let me see the previous ones. Not this one. Relational operators. If, then, and we have else. So if, after if, we have then, and then here we have else. If this, then this, else is this. So now check it. Yes. Now it's okay. It prints A is 1. This returns 1. A is 1. What if A is 0? Quit. If, then, else. If it's not equal to 0, yeah, I'm actually checking the wrong thing, like because of I've been programming for a while. I'm making a wrong check, so I need to check if it's actually this is not equal to 0. As you can see, if A is not equal to 0, A is gonna be 1, or if A is not equal to 1, A is gonna be 0, otherwise A is gonna be 1. This should be the correct check. Now A is, as you can see, A is 0. Let's change the A. Let's make it 1. Now A is 1. So okay. Now that's okay. This is logical OR. If one of the operands is true, then the condition becomes true. Logical OR. So for example, we can actually check, let's make all of these comment. We can actually have to select multiple lines and to put a comment in Vim. Visual mode, select the lines. Okay, so I actually done the same thing here, but are they commented? No. Run a command to comment the lines. You'll see you're working with the visual select lines. Run a command to comment the lines. Type S and press enter. This command substitutes the beginning of each line with a comment character. So you will select the lines like this. Okay. Now press S. Yeah. Now we have commented them out. So to comment these lines in Vim, you just basically need to select the lines. Let's uncomment it. The similar approach we will use again, not the insertion mode. In visual mode, you will press this one. This time S, again like this. And this one, and then this is for the uncommenting. Commenting, select the lines. We are in visual mode, S, this one, and this. Okay. Commenting the lines, visual mode. When in visual mode, you press the semicolon and then you go with you press semicolon and then you type these to comment it. Uncommenting the lines, you are going to the visual mode, semicolon, basically the same thing. Yeah. This one, and this. So anyways, and then we were checking for the these values. We're checking for the OR and the AND operations. So let's check the OR and AND operations. So let's say we have a variable. I have commented this line, but actually we don't know. That's the shebang. And now let's say A is, let's say 10 and B is, let's say 25. And you want to check the OR. If one of the operands is true, then the condition becomes true. So that's the logical OR, which is this symbol. So you can check if the variable of A is less than the variable of B, or A is less than B, which is true, right? Or the variable of B is greater than 100. This is false. B is not greater than 100, but this whole stuff is actually should be 1, right? We say then that you need to echo expression evaluates to true, else you can take this one, expression evaluates to false. Let's try it. And the file expecting, yeah, I forgot to put this, and the file in insertion mode, expression evaluates to true. Yeah, and they have also the logical AND. How you have the logical AND? Let's take the same expression. Instead of O, you change with A. Now the expression should evaluate to false. I mean, if this is 1, so it's this whole statement should evaluate to false. Okay. And what else? There are various operators supported by each shell. We will discuss in detail about the Bourne shell, the default shell in this chapter. We will now discuss the following operators: arithmetic operators, relational, Boolean operators, string operators, file test operators. And the string operators. The following string operators are supported by the Bourne shell. Assume variable A holds ABC and variable B holds EFG. Then we can check these string operations. String operations.sh. We are in insertion mode, right? Put this in .sh. Let's say A holds ABC, for example. We can show the examples with the double quotes. Inside the double quotes, we put the strings here, ABC, and B is EFG, let's say. If we can check for the equality here is equal to B, then echo if A is equal to B, else we need to get rid of this place. Quit edit anyway. It's gone anyways. It's really, sometimes it's really hard to adapt to the Vim. So A was ABC, B was EFG, and we can check if A is equal to B, then echo equal, else equal not equal, not equal. So we can check everything with this. Check if the value of two operands are equal or not. If values are not equal, then the condition becomes true. Checks if the given string operand size is is 0. If it's 0 length, then it returns true. It checks for the 0. So this is not 0, so this is not true. This returns 1 if it's 0, so if it's not 0, it returns false. So this is going to return false. Checks if the given string operand size is non-zero. If it's non-zero length, then it returns true. So is not false. Checks if the given string operand size is non-zero. If it's non-zero, returns true. So this should return true, not false. Checks if string is not the empty string. If it's empty, then it turns false. File test operators. We have a few operators that can be used to test various properties associated with the Unix file. Assume a variable file holds an existing file name test, the size of which is 100 bytes and has read, write, and execute permissions on. So we have also we can make some like operations on the files. Assume a variable file holds an existing file name test, the size of which is 100 bytes and has read, write, and execute permissions on. Checks if file is a block special file. If yes, then the condition becomes true. Checks if file is character special file. We can check the file test operators later. C shell operators. Following link will give you a brief idea on C shell operators, the corn shell operators, Unix shell decision making. In this chapter, we will understand shell decision making on Unix. While writing a shell script, there may be a situation when you need to adopt one path out of the given two paths. So you need to make use of conditional statements that allow your program to make correct decisions and perform the right actions. Unix shell supports conditional statements which are used to perform different actions based on different conditions. We'll now understand two decision-making statements: the if-else and case exec statement. If-else statements are useful decision-making statements which can be used to select an option from a given set of options. If phi, if-else phi, if else phi statement. Most of the if statements check relations using relational operators discussed in the previous chapter. The case exec statement. Is anyone? I cannot see the YouTube screen. I'm not sure if anyone is really watching. Let's see my channel. Chapter, the case exec statement. Is anyone? You can use multiple if-else statements to perform a multi-way branch. However, it is not always the best solution. You can use multiple if-else statements to perform a multi-way branch. However, this is not always the best solution, especially when all of the branches depend on the value of a single variable. Unix shell supports case exec statements, which handles exactly this situation, and it does so more efficiently than repeated if-else statements. You can check that later. Shell Unix Linux shell loop types. In this chapter, we'll discuss shell loops in Unix. A loop is a powerful programming tool that enables you to execute a set of commands repeatedly. In this chapter, we will examine the following types of loops available to shell programmers: the while loop, the for loop, the until loop, the select loop. You'll use different loops based on the situation. For example, the while loop executes the given commands until the given condition remains true. The until loop executes until a given condition becomes true. Once you have a good programming practice, you will gain the expertise and thereby start using appropriate loop based on the situation. Here, while and for loops are available in most of the other programming languages like C, C++, and Perl. We have the nesting loops, and we have the while command. This is loop 1, the outer loop, and we have a do. We have a do while here, right? As you can see, this is a do while, and then another do inside this do while. After this do while, there is this do done. So let's see. A is equal to 0 while this is loop 1. So what is this here? I mean, like inside the double quotes, how this is treated. I'm not sure how. I'm not sure how it even like evaluates this. When A is, for example, 10, what is the value of in one shell? Okay, 10, but this variable is inside the double quotes. So it's like this. Okay, then it substitutes the variable to this place. This is while this is 0, still 0, so you are going to the do, b becomes 0, right? Well, greater than or equal to, yes, it's correct. This is 1, this becomes 1, as you can see. Do this, this is the while, this is the first loop, and we have a do. Inside this loop we have the do statement, and then we initialize the b with this variable of a, which is 0, and then we have another while here which checks while is greater than or equal to, this is true, so this while loop is not executing. I'm just trying to understand this. For example, a0 less than, this is the less than, while a is less than 10, yes, this is true. Do this, the while loop executes the given commands until the given condition remains true. Until it remains true. Until the given condition remains true. So while this less than 10, which is true, then b becomes 0, and while b is greater than or equal to 0, which is true, stays true, and then do echo, and the value of b is 0, right? 0. And then b becomes expression b minus 1. B is right now, what is the value of b? B is minus 1 now. And then minus 1 greater than or equal to? No. We are getting out of this. And then you echo the value of a. A was 0. Now we print a equals 1. And a equals 1 here, equals 1, less than 10, b becomes 1, right? Greater than or equal to 0, yes, so we print b, which is 1, b becomes 0, and then I'm trying to understand this. A is less than 10, b is a, b is greater than or equal to 0, yes. Do the value of b, which is 0, right? This is the first echo, and then it goes to another statement. Expression of b is now minus 1, and we got out of this. And now we echo a plus 1. A was 0, now a is 1. Okay, then this whole thing is okay. A is 1 now, and b is 1 now. B is greater than or equal to, yes. Then what is this? Echo minus nb. What is this? These are b's. An option lets echo avoid printing a new line character. So this avoids printing a new line character. And we put b here, you know, b becomes the value of a until the 9, and b becomes b minus 1, b becomes 0 here. B becomes 0, and you echo. When you echo, you actually go to the new line, and a becomes 1, a1, b1, yes. We put the b, and then the b becomes 0. Do done, yes, and then you echo. Yeah, let's try to understand this one. This is loop 1. Yes. Echo without a new line. We put the B. B becomes -1. It's done. Now -1 is greater than no. We got rid of this while loop. While 2, done. We got rid of this while loop. Then we have echo, and then A is 1. A is 1. A is 1, then B is 1. B is greater than or equal to yes. We put the B and the space, and now B is 0. And B is 0, greater than or equal to 0, yes, true. And then echo this, we echo the 0, space. B becomes -1. Yes, done, finished. And now A becomes, A was 1, now A becomes 2, and then B becomes 2, and it's something like this. Yeah, so it took a long time to understand that, but it's actually quite tricky. The infinite loop. In this chapter, we'll discuss shell loop control in Unix. So far, you have looked at creating loops and working with loops to accomplish different tasks. Sometimes you need to stop a loop or skip iterations of the loop. In this chapter, we will learn following two statements that are used to control shell loops: the break statement and the continue statement. We have the infinite loop. All the loops have a limited life, and they come out once the condition is false or true, depending on the loop. A loop may continue forever if the required condition is met. A loop that executes forever without terminating executes for an infinite number of times. For this reason, such loops are called infinite loops. Here is a simple example that uses the while loop to display the numbers 0 to 9. So let's say do and done, and we have until. V until loop.ch A is 10 until the value of A is less than 10. Do echo the A, and then change the value of the A, xbr A plus 1 backtick, and done. Make this executable. Yeah, so until this less than 10, until the value of A less than 10, put the value of A and make the A 1, because A is always greater than or equal to 10. Until less than 10, until less than 10, but it never becomes less than 10. This loop continues forever because A is always greater than or equal to 10. Until, this will execute until A is less than 10. So for example, if A would be 0, now this would work. A is 0. Now it should work. echo a xpr a plus 1. Now try it. And a you can also change it with the while loop. Yes, now it works until it shows the while loop, but it so puts until ChatGPT until loop bash. The break statement. The break statement is used to terminate the execution of the entire loop after completing the execution of all of the lines of code up to the break statement. If then steps down to the code following the end of the loop. The following break statement is used to come out of a loop. Break. The break command can be used to exit from a nested loop using this format. Here and specifies the nth enclosing loop to the exit from. So let's copy this. What is this? The break example.ch. Ctrl+V. Need to get rid of this. So let's see this code. We have a while loop. Since a is less than 10, we have do. We print 0, and then if a is equal to 5, then it breaks. So it's not equal to 5, by the way. We put 0, and then a becomes 1. We print 1. A becomes 2, 3, 4. We put 4 on the screen, and then a becomes 5. We echo 5. If e equals equal to 5, then we break. When we break out of this stuff. So it should be print from 0 to 5. X break example. Yeah, 0 to 5. Here's a simple example of nested for loop. The script breaks out of both loops if var1 equals 2 and var2 equals to 0. So we yet another loop.sh. Let's copy and paste it. For variables in 1, 2, 3. Here's a simple example of nested for loop. This script breaks out of both loops if var1 equals 2 and var2 equals to 0. This script breaks out of both loops if var1 equals 2 and var2 equals to 0. Let's check it out. This first becomes 1 and this will becomes 0 and do. If var1 equals to 2 and var2 equals to 0, we break. Then break 2. What do we mean by break 2? Else echo var1 and var2. So 1, 0, we have 1, 0, we have this becomes 1, this becomes 0, and then this becomes 5, 1, 5, and then this becomes 2 and this becomes 0. Then we break the 2. You have break command with the argument 2. This case the difficult condition is met. You should break out of outer loop and ultimately from the inner loop as well. If condition is met, you should break out of outer loop and ultimately from the inner loop as well. So I can see that this break causes this to get out of this for loop, but it also gets out of, because since it gets out of this one, it's a really tricky question, because what is break to here? Exit both the inner loop and outer loops when specific conditions met. Let's break down the script and let's explain the person. To break out of two nearest enclosing loops. So this break to above means to get out of two enclosing for loops. The continue statement. The continue statement is similar to the break command, except that it causes the current iteration of the loop to exit rather than the entire loop. This statement is useful when an error has occurred, but you want to try to execute the next iteration of the loop. Syntax continue. Like with the break statement, an integer argument can be given to the continuous command to skip commands from nested loops. Continue n. Here n specifies the nth enclosing loop to continue from. We have another example here. This time, continue statement.sh. Now let's look this one. We have it's an array. It's called nums array. And for num in nums, this is the variable. We check the expression of modulus of the number that we take. So it's going to return in the first one 1, in the second one 0, in the third one 1, in the fourth one 0, in the fifth one 1, 6 1 0, 1 0 1 0. It's going to be like that, right? Because we are checking for the even numbers. If this value that obtained from here is equal to 0, then it's an even number and we continue it. Why we continue it? When we continue this one, we are actually not getting out of this for loop. We are actually going to the next iteration of the for loop. So this is, yeah, for every 2 times we will find an odd number. It's the 1 and 2. So let's see, chmod plus x, continue statement. Continue statement. Odd, even, odd, even, odd, even. It goes like that. Next one. What is substitution? The shall perform substitution when it encounters an expression that contains one or more special characters. Here the printing value of the variable is substituted by its value. Same time this is the new line character is substituted by a new line. The shall perform substitution when it encounters an expression that contains one or more special characters. So let's see. Let's say substitution.sh. So we have a variable like a, and you want to echo e, value of a is this, and then a new line character. Following is the result without e option, but when you put the v option, you actually have a new line substituted. Plus x substitution. Here we have a new line. So how we can actually see this? How we can see this? Is there any like bash help? Of course there is bash help. GNU bash it should have a man page. What is E here? Let's see the E. We can actually search for it. Quit man bash grep for E. From the left side you can check every stuff that have E, especially these flags. E flag. Exit immediately if a pipeline, which may consist of a single simple command, a list or compound command. Not this one. This is man echo, right? Enable interpretation of backslash escapes. It enables the interpretation of the backslash escapes. So you can actually ring a bell. Let's ring a bell. Anyways, you can check everything from here. Command substitution. There is also the thing, like for example, in the job interviews, it's usually asked like how to put a line to a text in Unix in terminal. You need to append it. Yeah. Echo. This is the print. And this is the stuff. So for example, let's check echo and grep for this one. Man echo grep syntax error near unexpected token new line. Man echo grep append right, but it's here menu page of echo line. Summary of less commands marked with we should have line editing. Yes. How can I find in echo manual? So it's man sh command interpreter. It's the shell. So redirection operators. In these redirection operators, we need to get to grep for this. The shell reads input in terms of lines from a file and breaks it up into words at white space. The shell reads input in terms of lines from a file and breaks it up into words at white space. Lengths and tabs. And it's certain sequences of characters that are special to the shell called operators. There are two types of operators: control operators and redirection operators. Their meaning is discussed later. It's a redirection operator. So redirections appends standard output to the file. So this appends. So for example, quit this. Let's say echo can to the which file is this? This is the last file was, it's going to issue an error. Let's clear it. Last file was the substitution, right? To substitution.sh. When you open this substitution.sh, now there's here, to get rid of this, of course. So you can do this. Pop. This is okay. The backslash, alert bell, backspace, new line, horizontal and stuff. So we substitution.sh. This is the new line. But is it the same? I mean, the new line here and the new line as in the C the same? So change directory to C codes. Like C code snippets. So for example, when you let's open the VC code here. Yeah, it's like this way, new line. Not this one, but this one. Anyways, I'm just trying to make sure everything is okay, because they always end up with like some silly questions. We check the substitution, command substitution, and command substitution is the mechanism by which the shell performs a given set of commands and then substitutes their output in the place of the commands. The command substitution is performed when a command is given as like this. Let me check my telephone for a while. Command substitution is generally used to assign the output of a command to a variable. Each of the following demonstrates the command substitution. So in this video I have checked for the, I think it's enough for now, and in the next video I will check for the substitutions, quoting mechanisms, input output redirections, shell functions, and the man page help. So let's see in the next video. Bye.